All right, in the first part of this video series, we talked about the differences between scalars and vectors and sort of the fundamentals of motion terminology. In this case, we're going to actually physically start talking about how the vocabulary deals with the different types of motion. All right, as a quick reminder, a scalar is a quantity with magnitude only. That means it has some amount and some unit. A vector means it has magnitude and direction, which means you're going to have a number, a unit, and some kind of a direction, whether that's a simple plus minus or an up, down, east, west, anything like that. Distance is a scalar value that measures the path traveled. Now remember, that's the physical path that is traveled. Displacement is a vector quantity measuring the straight line distance between the ending point and the reference point, or an ending point and then some other earlier point, as it doesn't actually have to be the reference point. Alright, so the first thing is speed. Now speed is the rate at which distance changes, and as you know, for any rate you're talking about dividing something by time. In this case, you're taking the scalar quantity distance and dividing it by another scalar quantity time, and you end up with a speed, which is a scalar quantity. Alright, you have examples: 65 miles per hour, 3 furlongs per fortnight, and 0.56 centimeters per second, so snail speed. The next one is velocity, and velocity is the rate at which displacement changes. Now remember, velocity is a vector quantity dealing with displacement divided by a scalar quantity time. So it does since displacement is a vector quantity, velocity is a vector quantity. Now you can't always see velocity as speed with some kind of a direction, because it doesn't always work that way. Now remember that what happens when you have a directional change in the process. Remember how displacement became very, very short. So in some cases you can look at speed or velocity as speed plus direction, but not all cases. Okay, now again, you must have magnitude, you must have direction. Examples: 65 miles per hour east, 5 furlongs per fortnight east-southeast, and 0.056 centimeters per second up. So we've got a snail traveling up a tree. Acceleration. Acceleration is the rate at which velocity changes. Now there is no scalar equivalent to acceleration. Alright, acceleration is a vector because velocity is a vector. An object is accelerating if it is increasing its speed, it's decreasing its speed, or changing direction. And it could also be some combination of speed and direction changes. You can have both positive and negative acceleration. Now you can't say negative acceleration is the same as deceleration, because only some cases apply where it's decelerating. Alright, so positive acceleration occurs when an object is moving in a positive direction and increasing its speed. An object is moving in a negative direction and decreasing its speed. A negative acceleration occurs when an object is moving in a positive direction and decreasing its speed, or an object is moving in a negative direction and increasing its speed in the negative direction. So the way to think about this is that the cases where you've got deceleration is the case where an object is moving in a negative direction and decreasing its speed. So in other words, it's going from a high negative speed to a lower negative speed. So it's getting closer to zero. Or you've got an object moving into a positive direction and it's slowing down. So in either case, those are the only cases that you can define deceleration. Other than that, we talk about positive and negative acceleration. And in general, I would recommend that you stick to that and avoid the word deceleration. So examples, 14 centimeters per second squared, 0.6 miles per hour per second. So there has to be two time units and a single displacement unit. Okay, 3 meters per second, which is the same as 3 meters per second squared. All right, now putting it all together. If a car has a negative velocity, negative acceleration, and negative displacement, the car is moving away from the reference point in the negative direction. So it's kind of behind the reference point. The car is continuing to move in the same direction, and it is moving, it isn't stopped. So it is moving in that same negative direction. So it's moving away from the reference point in that same negative direction. And it's increasing speed in the negative direction. Okay, so it's moving. So if we define to the left as negative, so it's moving to the left, it's moving, so it's continuing to move, and it is speeding up and moving to the left faster and faster and faster. Now the last term that we use is jerk, and jerk is the rate at which acceleration changes. It's a vector quantity, and jerk is a measure of how fast an object is changing direction. Okay? So in other words, how fast it's increasing the rate at which it's changing direction. Or how fast it is changing its rate. So in other words, how fast it's increasing and decreasing its speed is a good way of describing it. Now, the way you want to think about this is when you suddenly stomp on the brakes in a car, you jerk forwards. All right, now there are two types of each of these measurements. You have instantaneous measurements, which are snapshots. So at some particular point in time. So in other words, if you look at the speedometer in your car, you're looking at instantaneous speed. Okay? If you had your speedometer and some kind of a compass, you could get instantaneous velocity. Okay? So it's where an object is at a particular point in time. So its position at a given point in time. How fast it's moving, its speed or its velocity at a particular point in time. Its acceleration at a particular point in time. Now the other one is average measurements. So those are longer term time periods. Okay? You can find the average of two positions. Okay? Or find the displacement and divide it by the time interval over which it takes place. So that would be average velocity. So if you went from the reference point to 3 meters in 3 seconds, right, that's a difference of 3 meters, so that's your displacement, and you divide it by 3 seconds. So that would mean that your velocity would be plus 1 meter per second.